Let us look at list interface. List represent ordered collection of elements. Ordered means indexing is there, and there may be duplicate elements also. So list interface is extending or inheriting from collection interface. So here I have the list interface. Interface list extends collection. So list interface extends the collection interface. So whatever the methods present here, they are also present in list interface. Everything is present. Plus extra methods are there because it is ordered, indexing is there. So extra methods are there. So as an example, I have drawn this diagram for representing collections. So now I have given indices here. So now it is representing a diagram for list. This is not actually list. Don't take it as an exact diagram for a list. Again, I am telling you, just for explanation purpose, I have drawn array like, right? And I am calling it as a list. As it is ordered, this indices I have given. Now there are some extra methods in list that are using indices. So let us look at those methods. See, add method, first method. Add is already there. Add and add all, it's there. So one more add is there. Add index an object. So this is similar to this one, right? Add e. But what is the extra? Index. So this method add will add an object. Where it will add, we don't know. Most of the time it will be at the end of the collection. But this add will insert an element at a given index. Suppose I want to insert k at index 4. So it will move f and e, and here it will insert k. So I can mention the index, so it will make space for that element and then it will insert that element or object. So adding at a given index, this is possible. So now you can easily remember, there is an add method, add all method which will add collection, and one more add method with index. So list is having those two methods as well as this method. The next method is add all. So total 4 methods are there for adding one element or collection of element. So this is similar to this one, but you can mention index. This is similar to this one, add all, where you can mention the collection, and here you can mention the index also. So if I have to insert more than one values from another collection starting at some given index, suppose I want to insert 3 objects, let us say PQR, and I want to insert at 2. So PQR will be inserted by shifting these objects, right? Don't worry about the space again, just diagrammatically I am showing you. These 3 will be inserted here, right? So C and D will start coming from this point onwards. So it will make space by shifting the elements and insert the element. So add all this collection from some starting index. So you can insert the element from some point by mentioning the index. Now add and add all, right? There are 2 extra. Now list is having those methods also, these methods are also. So whichever one you want, you can use. Now next is remove. You can remove an object by giving an index. Like suppose I want to remove an object from given index, that is 4, k I want to remove. So if I want to remove k, k will be removed and e and f will be shifted here. So it will remove the object and it will move all other objects and change their indexes. The next method, get. Say this is over. Remove already we have, so already 2 methods were there. Now one more is there with index. Now next method, get. So you can just know the object at a given index. I want to know what is there at index 5. So at index 5 I have f. Get 5. So you can get the object present there. Get 2. You can get the object present here, C. So get will give you the object. Now at a given index. The next one is set index an object. Now I want to set means it will replace the object at a given index. Suppose I want to replace at index 3, whatever is there I want to replace with k. So set at index 3, new letter k. So 3 is this one. So this will be changed to k. So you can change the object at a given index. So this is set. So there is a difference between add and set. Add will insert an element by making a free space. Set will change that object or change that element. Now next method is sublist. So till here we have finished. Now the next one is sublist. So you can get the part of a list, that is a collection of few elements you can take. I want the elements from 1 to 4. So B, C, K, E, let me change it to D. So B, C, D, E, I want these elements. So you can give the index from and to. So from this point to this point, so you can give two indices, 1 to 3. So starting index and index. So you can get those elements. It will not remove them, just you will get the copy of those objects. Then next, searching. Here we had contains. So contains will search for an object and returns true or false, present or not present. But now as indices are there, I want to know where it is. I want to know where is C. C is found at index 2. Index 2. So for that we have a method index of a given object. Index of C. So if I say index of C, I'll get the index 2. Index of E, I get the index 4. So index of method will give you the index of a given object. Then one more method is there, last index of. So this index of will start searching from left to right, and the last index of will start searching from right towards left. So from that side it will search. So if you have duplicates and you are searching for something, so you can search from either end, from the starting or from the ending. So if there are more than one objects, you can look for the first one or the last one, beginning one or the ending one. So index of and last index of, these are useful. Now last two more methods are there. See, already I have explained you about iterator. This will allow us to access all the elements in a collection. But list is a indexed collection. So there is one more iterator available, that is called as list iterator. So iterator is also there, list iterator is also there. I'll explain separately in another video about these two. But here I will show you the differences, that this iterator allow you to access the element only in forward direction, but this list iterator allow you to access the element in either direction. You can move forward also, you can move backward also, you can go to the next element also, you can go to previous element also. So you can access the objects in any direction. This is unidirectional, this is bidirectional because it is indexed. And also you can get the list iterator from the beginning of a list or from some starting point. You can mention an index here, and I want the iterator just from index 3 onwards. So from here you can either move forward or you can move backward. So starting point will be, index will be 3. So you can get the iterator there also. So these are the method of list iterator. So you should remember this plus these. So as I said that if you remember this, most of your work is over. Now based on that only, few extra methods are there with the indices. If index is there, it is ordering is there, then definitely few methods will be extra. So those extra methods are there. Now one more interface is remaining, last one, that is set. And the good thing is that it doesn't have any extra methods. It extends collection interface. So here I will write interface, right? Interface set extends collection. Any extra methods? No extra methods at all. So it is as it is, same as collection interface. So if you know these methods, you know about collection, you know about set. And if you know extra methods, you know about list also. So set doesn't have any extra methods, it is having only these methods. Set is unordered collection of objects and unique collection of objects, that is distinct objects are there. So that's how it doesn't have indices, so no extra methods, same methods are there. So we have finished collection, list and set. Now one more, queue interface is remaining. So quickly I will show the methods. Already you are familiar with them, so just you have to know about its methods. So let us look at queue interface. Let us learn about queue interface. This queue interface is useful for supporting FIFO mechanism, first in first out queue, that is first in first out mechanism. So objects are inserted from one end and deleted from another end. So if you look at this as an example, now from here this side the elements are inserted, from this side they are inserted, and from this side they are deleted, if I represent this as a queue. So queue interface is extending from collection. So all these methods are there, plus extra methods are there for queue mechanism, special queue mechanism. Only few methods are there, let us look at them. See, the first method is add. So it will not ask you where to add, simply it will add at the end. That's all. Because it has to support FIFO mechanism, a new object will be inserted at the end of the queue, that is here. If I'm inserting a new element, let us say K, so K will be inserted here. And after the last element, a new element will be inserted. The next, these are similar in their performance, but there is some difference. Let us see. Poll, this will remove the first object. As it is FIFO, so first in, first out, so it will not ask which element to remove. It will remove first element only, means first object is removed. Poll will remove the first object. And if the queue is empty, then poll will return null. It will return null if the queue is empty. Then one more method is there, remove. This also does the same thing just like poll, but only the difference is if queue is empty, then it throws exception, that is no such element exception. If object is not there, if it is empty, then it will throw this exception. So it means when you are calling this method, you should be ready to check whether it is null or not. And if you are calling this method, then you should be ready to handle this exception using try and catch. So which one you prefer, you can take that one. So it means both the methods does the same thing, they remove the object. But in case if it is empty, then one will reply you by returning null and other will reply you by throwing exception. So if you are calling this method from somewhere, then you should be ready for these two. Then last method, again these two are similar. So if I just want to know the object or the element present in the beginning, before removing it from the queue, just I want to see what is there inside the queue. So the first element is A. So if I just want to know what is the next element that is coming out from the queue, so the methods are peek. Peek will give you the first object in the queue. And if the queue is empty, it will return null. Next, element is there. That also does the same thing. It will give you the first element. So these two are same. Only the difference is if queue is empty, it will return null. If a queue is empty, this throws no such element exception. Same exception it throws. So you should be ready to catch that exception if you're calling this method. So these two methods respond you by throwing exception in case of failure, and these will respond by returning null values. So that's all. These are the methods in queue interface. So all the methods are same as it is plus extra method. So these methods confirms FIFO mechanism. So that's all about all the interface, useful interfaces about collection classes. So we have seen collection, then list and set, and then queue. So in this video, I have explained you about all the methods of these interfaces. So we will be using them in the coming videos. So that's all in this video.